In this recording, we're going to solve exponential equations. Equations that do have a common base, but the exponent is unknown. Once you jot down that heading in the first example, we'll walk our way through these examples together, and I'll give you a little practice time. Okay, so as you look at this first example, it's got 9 to the 2x plus 4 equals 9 to the x minus 3. Now, if both sides are equal, and the bases are the same, in other words, the 9s, doesn't it logically follow, therefore, that what I'm pointing to, these two exponents, must be the same? That would be the only way that both sides must be the same. Well, let's make a note about that. We'll say if the bases are equal, the exponents must be equal. All right, so this is pretty easy. From here, we just go ahead and say, okay, 2x plus 4 must equal x minus 3, and just proceed to solve that out. So why don't you solve that out and get your value of x? Play the recording when you're ready. Okay, so hopefully you subtracted x from both sides, got a little x, plus 4 equals negative 3, subtracted 4 from both sides, and you ended up with x equals negative 7. And now all we can do is do our check. So in each one of these, you should do a check. So you'll have something like 9 to the 2 times negative 7 plus 4 power equals 9 to the negative 7 minus 3 power. And in both cases, you get 9 to the negative 10. That would be a pretty small number we could put in our calculator, but clearly if the numbers look exactly alike on both sides, they are equivalent. All right, so let's raise the bar just slightly. Number 2 is a little trickier. These do not have a common base. We know what to do if they have a common base. It's pretty easy. We set the exponents equal. If they don't have a common base, what we need to do is rewrite in terms of a common base. So how could we turn the 49 and the 7 into something with a common base? So let's make a little note about what we need to do over here. We're going to rewrite the 49 with a common base. In other words, how can you represent 49 with a base of 7? So the left side we'll leave alone. 7 to the 3x equals, and I'm going to use a little color coding here. I need to put something in the parentheses in place of 49 that is equal to 49. And of course, that would be 7 squared, right? So 7 squared is equivalent to 49. Therefore, I can substitute it in its place. So now we need to use our power property with exponents. On the left side, it's all set. Doesn't have any parentheses. On the right side, you have 2 times the quantity x plus 1. So we make it 7 times. And I want you to write down what you think the exponent is. This is a place where students sometimes make mistakes. I don't want you to be one of those students. Get this right. Distribute the exponent. Really critical. All right, so let's make a little note for ourselves here how we're going to do that. We're going to multiply the exponents. In other words, distribute and get 2x plus 2. Let's make a little note. Multiply the exponents. And the key thing is to distribute. A lot of students, if they make a mistake, will neglect to distribute that 2 to both terms. All right, from here it's pretty easy, right? We said if the bases are the same, then the exponents must be equal. So 3x equals 2x plus 2. Subtract 2 from both sides. We got our answer. X equals 2. We could sub it in and check it. Why don't you try to do this last one on your own? Play the recording when you're ready. Okay, so in terms of getting a common base, you might think, oh, I just use 8, right? 8 times 2. But that doesn't really work, because 8 times 2 is not 8 to an exponent. So we need a smaller number. You're going to start small. You might think 4, because 4 squared is 16, but there is no real easy way to make 4 into an 8 without getting into fractional exponents. So let's go even smaller. Let's do it as 2. So we're going to color code. I'm just going to use some colors here just to make things stand out for you. I'm just going to leave that blank space there. And I want you to put in parentheses something that has a base of 2 that's equivalent to a 16. I want you to do something for the 8, base of 2 that's equivalent to 8. Play the recording when you're ready. Feel free to peek at your powers table if you need to. Okay, so we've got 2 to the 4th power, that's the same as 16. 2 to the 3rd power, that's the same as 8. From here, not too bad, right? We know how to distribute the exponent. So 2 to the 4x, let me write that clearly, 4x equals 2 to the 3x plus 2. Exponents are equal. I mean, the two sides are equal and the bases are equal, so the exponents must be equal. We subtract 3x from both sides. Oh, Mr. Clinton, you didn't distribute. Shame on you. Let's get it right. Let's erase everything. Back, 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 back. All right, you got to get a plus 6 in there. So 4x equals 3x plus 6. Okay, we would have caught that if we took time to check. That's why you always want to check on these problems. It's really easy to check, especially if you have a calculator. Just sub it in, and it would check out. All right, let's jot down our steps, because sometimes it's handy for students to have the steps available to them in terms of what we do. First step, if necessary, and it wasn't in our first example, it was in our second and third examples, you're going to rewrite with a common base. It's usually a small number, like a 2 or a 3, but sometimes it's a 7. Next step, if necessary, multiply the exponents to eliminate the outside parentheses. That's what we did in our previous couple examples. We multiplied the exponents here, 2 times x plus 1. Here I messed it up, right? I didn't distribute very well. Got to make sure we're distributing. Maybe make a note to yourself. Distribute. Set the exponents equal and solve. That's easy. Now if there's one more step, what would that step be? Could it be a single word? What would that one word be? That would be our step 4. You're right. Check. All right. For your practice, I've got 4 examples I want you to work on here. I want you to pause the recording. Don't play it until you've gotten as far as you can. Little curveball here on 1/9. You're going to have to maybe look at your powers table to see how you can represent both of these bases with a common base. Play the recording when you've got some answers. All right, so hopefully you took time to work these out, pause, and if you haven't, please go ahead and pause and actually work these out. I want you to do the thinking before you actually confirm your answers. So this first example, example A, is pretty easy because the bases are already equal. So we'll essentially say that the exponents must be equal. X plus 1 must be equal to the quantity 2x minus 4. From there, we can just solve it out. It works out that x equals 5. Okay. Example B. Well, 5 looks like it could be the common base here. So I'm going to keep the left side alone, 5 to the a plus 1 power. I'm going to do something with this 25 and write it as a power of 5. So it's going to be a 5 squared. Okay? So at this point, we've got a 5 to the a plus 1 equals 5 to the 2a. When you work those out, set those exponents equal. Turns out that a is equal to 1. Example C, you're going to need a base that can be made into a 32 as well as an 8. So in this case, we're going to use a 2. So 2 to the 5th is equivalent to 32. That's all raised to the y power. And over on the right side, you can make 8 into a 2 cubed. So when you set these exponents equal, you multiply it out. 2 to the 5y equals 2 cubed. And set those exponents equal. You're going to end up with a fractional answer, but that's okay. We can handle that. 5y equals 3. Y equals 3 over 5. Final example, and this one may have thrown you for a little loop here. When you have this fraction here, to create fractions, let's make this note to ourselves, because this sometimes messes students up. To create fractions, you're going to want, with powers, I guess I should say, to create fractions with powers. What kind of exponents are we going to need? Did you check out your powers table? Okay, you're going to need a negative exponent. Okay, let's make that note. So anytime we have a fraction with a, trying to make a power into, we're going to use a negative exponent. So that would, of course, be 3 to the negative 2 equals 3 to the 2x. When you set those equal, negative 2 equals 2x, and x equals negative 1. Thanks for watching. Now try that quiz.